So let's take a look at an example. This table here describes the distribution of a random sample of 466 individuals from the US, organized by political party, and views on the circumstances under which abortion should be legal. One individual from the sample is selected at random. And we want to do two things with this data. One, we want to find the probability that the individual believes abortion should be illegal in all circumstances, given that they are Republican. And two, we want to find the probability that the individual is a Republican, given that they believe abortion should be illegal in all circumstances. So these sound very similar, but the order of the events differs, right? The probability we're looking for and what we're assuming to be true are different, okay? But we are dealing with two events here. So let's first give mathematical notation for our events. So I'm going to call I the event where the individual believes that abortion should be illegal in all circumstances. And R is the event where the individual is a Republican. Okay? So number one, we want to find the probability that the individual believes abortion should be illegal in all circumstances, given that they are a Republican. Okay, so for number one, the probability we're looking for is that the individual believes the abortion should be illegal in all circumstances. But then we add an extra assumption. We're not just interested in all the individuals. We are assuming that the individuals are Republican, or the individual we pick is a Republican. Okay? So, in other words, we pick someone at random, and whoever picks this person tells you, hey, listen, I don't know what they believe in abortion, but I can tell you that they're a Republican. They're giving you that extra piece of information. Okay? So the extra information is over here on the right side. The vertical line means given. So we want the probability that the individual believes that abortion should be illegal in all circumstances, given that the individual is a Republican. Okay? So let's use our formula here to find this conditional probability. Now, in this case, all the outcomes are equally likely. So we want the number of outcomes in I and R divided by the total number of outcomes in R. That's the formula for conditional probability when all the outcomes are equally likely. Okay, so all we got to do is some counting. We need to count the number of individuals who are Republican and who believe abortion should be illegal in all circumstances. Okay? So here's Republicans. Here's the individuals that believe abortion should be illegal in all circumstances. And that is the total number of people that are both Republican and believe that abortion should be illegal in all circumstances. So that is the number of people we're looking for that numerator value. $38. Okay? And then we're going to divide it by the total number of Republicans. So just focus on that row with Republicans. There are 18 who believe it should be legal under any circumstances, 66 under only certain circumstances, and 38 illegal in all circumstances. So we want to put that together, and that will tell us all the Republicans that we could look at, right? So 18 plus 66 plus 38. 18 plus 66 plus 38. Okay? I'm going to throw that into a calculator off here to the side. 38 divided by 18 plus 66 plus 38. That gives me 0.3 1148. Okay, so about 31% of Republicans believe that abortion should be illegal in all circumstances. Okay, the probability that we select among the Republicans that the person we select believes that abortion should be illegal in all circumstances is 31%. Okay. Number 2. Now, very similar sounding problem. We want to find the probability that the individual is a Republican, given that they believe abortion should be illegal in all circumstances. So we're just flipping things around. Now we want to find the probability that the individual is a Republican. And given, what we're assuming to be true, is that we already know the individual believes abortion should be illegal in all circumstances. Okay? So using the formula, we want to find the number of outcomes in R and I divided by the total number of outcomes in the given I. Okay? Notice the formula is just a little different. Okay? In particular, the denominator is different. The event that goes in the denominator is always the given event. It's the second event in that list. Okay? Notice in particular that generally these two are not the same. You can't just swap these two. Okay? That doesn't work. Okay? So you got to pay attention to what order they're coming in. Okay? So first, number of outcomes in R and I. So number of people that we could select from that are both a Republican and believe abortion should be illegal in all circumstances. Okay? Now, it turns out that is the same as this. Order doesn't matter for this and. Okay? So there are 38 people who are both Republican and believe abortion should be illegal in all circumstances. And we didn't want to divide by the number of people who believe abortion should be illegal in all circumstances. So that would be this column here. Okay? So 66 of those people are Republican, 96 are independent, 62 are Democrats. And if we put them all together, that's all the people. I'm sorry, I'm looking at the wrong column, aren't I? Here. This column. This is the column where the people believe abortion should be illegal in all circumstances. 38 are Republican, 34 are independent, 12 are Democrat. And you put them all together and you get all the people that believe abortion should be illegal in all circumstances. So that's 38 plus 34 plus 12. Okay? And again, I'll just throw that into a calculator off to the side. So 38 plus 34 plus 12. And I get 0.45238. Okay? So about 45% of those who believe that abortion should be illegal in all circumstances are Republicans, according to this table, among these people that were surveyed. Okay? So, again, I really want to emphasize that these two are not the same. You got to pay close attention to the order your events come in. Okay? We got different probabilities here when we did the calculation, so we need to be careful of that.